add mapping M party secure learning party staging party. Okay. Then you have just a dummy structure. On this structure we are going to create the remaining things. So right, first let's check the document and do accordingly. Let me close this. Okay, first thing, PKSRC object, that is this column should come from the primary key from the source, that's the party ID from the landing table. So should be something like this, but I need to trim it. The first logic is very simple. I need to trim it and just connect it. To trim that, say add a function, string functions, trim. Okay, then party ID, PKSRC object, save it. That's the logic for the first thing. First thing is, why are we trimming? What is PKSRC object? Now this is nothing but the primary key from the source. And why do we trim it? Because in source the key might contain spaces and all that, and we don't want spaces. So that's why we are trimming that. Okay. Now the second logic, row ID object matched, that is this one. Okay. It is system generated to be used in load by row ID object concept. What is load by row ID object? I'll show you that later. That's an advanced topic. But as of now, just understand that this thing should never be mapped. So you should not map any value to this row ID object matched. If you do that, it'll behave in a strange way. Okay, so normally don't map. Then the third one, that is the name. Name is coming from the landing table, right? And I need to apply this plus this. First let's check this rule, then we'll go to this. First this. So go here, open a notepad. I need to remove the noise and digits and trim it and title case it before, that's the data quality rule. And sample data also I've given, that is this. So the objective is that you convert something like this to this. That's the objective. You see that here these characters are considered as noise. This digit is also a noise, and you have this, these are all noises. Okay, so you remove all these noise, and then you trim. Trim means you remove the spaces and then you title case it. So you see here that Sunil, S is capitals, M is capitals. Okay, and 1 minute. Right, so how to do it? Let's see. First I will do this. Let's see how we can remove noise and digits. To remove noise and digits, I can use a cleanse list. That's the best way. But try to understand that, see, this logic, this same logic, you can see it's here also, same logic. So I have to make it reusable. I have to make that reusable. Why? Because logic is same. So reusable in the sense, I'll make it a graph function. Graph function is reusable, right? So I'll make it a graph function. So let's go ahead and try to implement that. Yes. First create a folder, that is user library. So I'll just say customer cleanse. Here first we'll create a graph function. See, try to understand that in MDM MDM mapping cannot be compared with ETL mapping because ETL mappings are quite good to manage, but MDM mapping it's slightly difficult to manage things in MDM. It's slightly difficult. Okay, so what you do is you try to organize things. You try to organize things so that you can uh, manage things properly. How do you do that? You instead of creating things directly in the mapping, you create graph functions and call the graph functions. That way it is you can backtrack your logic or you can troubleshoot. But if you create everything in the mapping, it's very difficult to backtrack. So always try to, it's like divide and rule. Break it down into pieces and then manage it, right? So let's create a graph function. Gr, I'll just say cleanse name. Gr cleanse name. Okay. And here, and create one cleanse list. So cl cleanse, or I'll just say remove noise and digits. Just 1 minute. 1 second. Okay. So cl remove noise and digits. Create the cleanse list. Okay. Then I have right. So what we are trying to do here, we are trying to implement this remove noise and digits. Actually, that feature, this thing, it's already there. Informatica has given a default thing that is called as general noise. We can also use it and extend that. Okay, so we can also use that feature. How do I use it? So what do I do is I can extend this @hash, go here and add the @, then add a hash, then I have this quote, this one, then I have this already exists. Okay, right? So I can also use this list and extend it. So now let me test it. Let's see if it works. The digits will not be replaced. That's okay. So anywhere it's not working. Only this got replaced. So stop on hit must be false. Then test it. So it is working fine. The only thing is the digits is not getting replaced. To do that, you can also enter the digits like this. So you can enter 1 1, oh sorry, 1 0. Then you can have something like 2 0. You can do it something like that, or we have better technology. So what we can do is we can use regular expressions plus, so use regular expression. So anything that matches 0 to 9, right, that will be replaced with empty. So if I go here and test it, here I go, it works fine. Okay, so I can use that, or I've created my own cleanse remove noise. Okay, what I will do, that extra thing is I will implement all of this in the regular expression, single expression. Okay, and 1 second. Okay, so what I'll do is I will implement the regular expressions plus, then see here, let's try to understand the expression. What is the expression that I can give here? I can give in a name, anything apart from alphabets is invalid, right? So if I give something like something that is not a, or let's say this, something that is not A to Z or A to Z, something that is not a alphabet is invalid. So make this as regular, not exact. Exact won't work. Make it regular. Say OK. Let's go ahead and test it. Here, this must be anywhere. Stop on hit is not necessary now. Why? Because I just have single uh, thing, single what do you say? Only one entry I have. So stop on hit is not necessary. Otherwise it will be. Okay. So this is working fine, except you see the space is also getting removed. So that I don't want. So what I'll do is I'll also go here and mention a space. Okay. Space. Test it. So working fine. Okay. So this is working in fine. Now, so you understood, right? I'm just using anywhere and this, that is working fine. So let's call this cleanse list in this graph function. So call that one, call the cleanse list that we just created, CL, remove noise digits. Okay. And you pass this input to this input. And the search type can be what? Should I pass it from the source? No, it's a constant value. You don't pass it from the source. You create it. So you say add a constant, and that is anywhere. And you pass this value to the search type. Right? And the output to here and save it. I can go and test that. Here, test Sunil Monti. But if I test the complete thing, it won't work because these two things I have not implemented yet. I will do that now. But my first requirement is done. First thing is done. Now trim and title case. So remove that. You trim it. So add function trim, then title case. Then to the output. So that's the complete flow. That is the complete thing. Okay, again I'm telling you, anywhere is something, it's a constant that I'm passing. Why I'm not passing from source? Because it's a constant. I mean, why would I pass it from source? But this one is the input data. In the cleanse list, while I was testing, I used to provide the value directly here, and this one is anywhere. Test it. Right? But here I am providing these values. So you understood, this is like a function. Okay, so you would have seen 5 factorial, you would have seen 4 factorial. So this is n factorial function. So n is something that you need to pass dynamically, just like a function. So this is, I'm using this just like a C++ function. I'm passing value to that and getting something in return, right? And if I test the complete thing now, should work. Even if I include the quotes also, it should work. Working fine. That's what is this cleanse. The first thing. If you have any doubts on that, you can ask. So once this is done, go here, add the function, add this, call this graph function here. Okay, name to name here, save that. Okay, that is the first thing, that is this logic. Remove noise, digits, trim and title case. That completes the first requirement for the name. Now let's move on to the, if name is null, reject, and first let's check that, then we'll go to the blacklist. So if name is null, reject. So we are now talking about rejecting something. Okay, let's create a graph function for this logic, right? Let me create a graph function, and the name of the function would be reject null. So gr reject null, that's it. If it's null, just reject that. Okay, I have an input. Now I will check if this input is null or not null. If it's null, I want to reject that. Not null, no problem, pass it, right? So to do that, first I need to understand if it's null or not null, because that's the first thing. I have to understand that, okay, that is null. How do I know that if the input is null or not? To understand if an input is null or not, what I need to do is I need to use a function. So add a function and see here. So logic functions, is string null or is string empty? I need to use any of this. Is string empty is better because it can detect null as well as empty. Whereas is string null, this cannot detect null. Sorry, this cannot detect empty space. This can only detect the nulls. So I'll rather use this one, is string empty. Say okay. Now if I connect this, what's the meaning of this thing? You see a different color here. What's the significance of the color? The craze of color is, this is Boolean and this one is string. String, Boolean. That's what this yellow color is about. Right? So what will be this? This is Boolean, means binary, 0, 1. That is true, false. So if my input is null, what will be this value? True. If my input is not null, the value will be false. Okay. So let me try to connect this to here. I'm getting an error. Cannot automatically connect from Boolean to string. I'm getting an error message. Alright. It means that Boolean data type is not that much useful. Boolean data type is not useful. So what I want a string data type back. So I would convert this Boolean to string. Okay. So add a function and format Boolean, converts Boolean to a string. Click OK. Expand it, right click, expanded mode, connect this to here. So if it is true, what does it mean? If it is true, then my input is null. Is it correct? If this is true, input is what? Null. So just add a constant and say null and connect that here. And if it is false, that's not null. So add a constant and false, false, not null. See, this not null, it's a string not null. Do not compare null with NULL. You understand what is the difference between null, real null, and this NULL? This is not null, this is NULL string. Don't get confused. Then false. Then let's test this. This is just a null detector. So instead of reject null, I would rename that to detect null. Let's create separate components. gr detect null. So gr detect null. Okay. I can test it. If it is null, null, right? If some value is there, it's not underscore null. If it is empty, it's null. Empty null are different, but doesn't matters. I also want to detect nulls. That's something that I want. Okay. So null, null, right? Now, so but what is our objective? Our objective is if it is null, then reject it. So I have detected the null. That's something that I have done. But how to reject it? Let's create another graph function to reject that. So add graph function, gr reject null. All right. Now what I'm going to do here is I'm going to call this guy. I'm going to call this thing here. Okay, this detect, I'm going to call it here. Right? Call that detect null. You understand what I'm doing? I'm trying to break it down into pieces. I'm creating graph functions for small things. For example, detect null. Now detect null can be used in multiple places. So I made it reusable. So what does it do? You pass the input, output will be null or not underscore null, not null, right? So for example, save it quickly. Let's say test it. Null, output is null. Something is there, not null, right? Now, based on this thing, I would like to reject my customer. How do I reject the customer? But what we'll do is let's make this thing a bit better. Detect null. So what I'm doing here is the input, the output. Okay, the output is I'm losing my output input. If my input is Sunil, I'm not passing that here. So let me pass this. Sorry. So this is null flag. I'm creating a column called as null flag, and I'm going to map that to here, and the input will go to the output. It looks like a circus, like a circle, right? So in power center or in data stage, this flow will be invalid, but in MDM, no problem. It's not a problem. You will see that. See here. If it is Sunil, so this is Sunil output. This is not null, right? And if it is null, then this is null and this is null, right? Now let's use that here. See here, you can see that dynamically this is coming up here. I don't need to again bring it and all that, right? Now I'm going to use a null flag to reject the records. So I'm trying to like make it more and more usable, but let me put this down here. So what I've done is I have created something called as null detector. Okay, second thing is reject based on null. What I can do actually is I can also create a graph function just for this. So if it is null, reject. If it is not null, no problem, accept it. So I can also create a separate graph function. Let's create a separate graph function just for this feature, right? So reject based on null, or what I can do is gr reject null. Let's say what I will do. Let's just You understand what I'm trying to do is I'm trying to combine first detect null, then reject null. Okay, detect null and reject null. So in the reject null, I will not call this. I'll rather use, see, it's like this. First I will use this function, then after that I'll use this function. So what is the output of this function? I know if something is null or not null, right? So here also I will make this as input and null flag, right? And this null flag tells me if it is null, it's null. If it's not null, it's not null. Then I need to use something called as a condition, add a condition. What is add condition? This is like case statement. So case when then, case when then, case when then, or something like if then else. If this, do that. If this, do that. Right? So add condition, and this will contain null and not underscore null. You can drop this default. So what is this? This is nothing but this value, null value. This case flag is nothing but the null value. It means, see here, if it is null, it will follow this logic. If it is not null, it will follow this logic. Looks same, right? Let me show you. If it is not null, then it is this logic. If it is null, we have to reject, right? So we'll use a special function here. We'll use a reject function here, right? So call the reject function, add function. In the miscellaneous, it will be there, reject function. Okay, right? And case value, input will go to the value here, and this will go to the output, and the message, the text, you can give a custom message, that is input is null. So when it is rejecting the data, you will see this message. You will see this message. Okay. So you understood, if it is not null, I'm just passing it. I'm not doing anything. If it is null, then I'm doing a lot of things. I am doing the rejection logic. It means I'm just rejecting that. Right? Say okay. Expanded mode. I see two inputs, case value, input. What is case value? What is input? Case value is nothing but this thing, null, not null. It means that this null flag must go to the case value. And input is what? That's nothing but the input. Goes here, output will go to here. And save that. Right? So it means that if my input is null, then and this will be null, then here I go. When I test it, I'm getting a message. Don't think that you are getting any error message. This is not an error message. This is a reject message. How do I know? You see this, input is null. I have given this custom thing, right? Input is null. So that's what I'm seeing here. Input is null. Right? Now, you understood how a reject function works. Now you might have a question like, okay, you said that the record should be rejected. Where is it rejected? I can see that in the screen. That's correct. You can see that on your screen this message because you're testing it. But when you run this, you will not see any message. When you run the job, which I will show you later, you will not see any message. You will see this record in your reject table. That's what will happen. You'll see this in your reject table. Okay? Say okay. Now, let's say if I give a valid thing like Sunil, and that is not null, test it. This is Sunil. It's not doing anything, but if I give this as null, it will reject. Now, if I give anything else in the flag, what happens? It's not rejecting. That's what is the meaning of this default flag. So you see star mark, right? Star means that's the default thing. If it is anything apart from null, not null, it will go to the default. The default is not null. If you want to change it, you can do that here, right? Now if I go and test it, we'll throw an error. Okay, so even if this is MJ something, it throws an error. That's okay. Now let's combine the pieces. So go to the mapping, call this function that we created. First is the detect null. Second is the reject null. So this to here, output to this input, this flag to this flag, this one to here. And save it. Okay, so see here, I'm explaining this again. I have one function, two function, three function. I have three functions. I'm combining all the three functions. First thing is dedicated to cleansing the name. Second, third functions. See, I have one, like for you it might seem like why I'm unnecessarily creating separate functions. I'm creating separate functions because I will make this thing reusable. That is, I would like to use this in other mappings also, in other logics. So that's why I'm making it like this. Otherwise, if you want, if you feel there is a confusion, you can also combine these two to create a single logic, single graph function. You can do it. That's fine. That depends. Okay. So what your approach is, you can do that. Then I'm just combining the pieces here. Simple logic. So just combine these three pieces here. You will see that it is slightly difficult to arrange things, like you don't have something like arrange all iconic or something to make this thing better. So if things are complicated, it's very difficult to manage the mapping. So that's why I am managing that in the graph function. So that's the reason why I am creating graph functions for small logic. Okay, I'm creating graph function for small logics. That's the reason, to make things simple. Because see, if I face an issue, I don't have to track it here. I don't have to track it here. I can directly identify the graph function and go there and track it. That makes life easier. Right? Now save it and let's quickly test this one. So I have something like this. If I give this value, then test it and just see the output below, working fine, right? If I give a null, I'm getting a message. Okay, and if something like this also, it should work. So 1 2 3 hash, it's rejecting because actually input is null, because this is not a valid character. First it is doing the cleanse, then it's detecting that. Perfect logic, right? So that completes the this one and this. If you have any doubt, you can ask, because I'm now I'll proceed to the blacklisted thing, how to implement the blacklisted. You have any doubts?
Hi, Sunil, I have one question.
Yeah. Yeah, Bharat, tell me.
Actually, in ETL, there is an option we can create a maplet, see something reusable objects. So same kind, the functions which you have created, can I reuse in any other mappings which you have created?
That's what I'm saying, right? Whatever I am creating in the graph function, I can reuse all that. For example, see here, if I go here, 1 minute. See, if I go here, okay, and if I create another mapping, let's say XYZ and some mapping, in that mapping I can call this. See, this is a different mapping. I can call this function. That's the main reason why I have created them as a graph function. What I could have done is, like, instead of doing that, I could have created the complete logic here itself, right? So directly go here and call the cleanse list here, and then call this. If you do that, it would look like a theater. So that's why that's one of the reasons to make it simple. Second reason is to make it reusable. I have created graph functions. Clear?
Yeah, it's clear. Yeah, thanks.
Okay. Now the third logic, the blacklisted. What's the concept of blacklisted customers? Now, wherever you go, you will see blacklist. A concept is something that's common only. For example, in, let's say you're running a telecom or any company, you will see that certain customers will be blacklisted. So how do I identify those customers? Normally, some people will try to log in or use vulgar or slangs in the names. So you understand what's a vulgar word and a slang. Now that's something that's, if you're getting a slang word in the name, if someone is entering, you must reject that. Okay, that's the objective here. So that's what we are trying to implement. Blacklist check. So let's, how to do that? Let's try to understand. To do that, let's say the blacklisted is Hitler. It's an offensive term. Let's say, not offensive to me, but let's say Hitler, Nazi, these two are offensive terms. No one can register as Nazi or Nazi party something. So if someone is trying to register as Nazi party, the name of the customer is Nazi party Hitler, then it should detect that and reject this customer. That's the objective. How do I do it? Same. Graph function cleanse list. Okay, in a cleanse list you create this 3 entry. So let's go ahead and say add a cleanse list, CL blacklisted customers. Okay, so in that cleanse list you create the entry. What is the entry? Nazi, just say Nazi Hitler, make it very simple. And Hitler. See, now the logic is slightly reverse. The logic is, if you're getting a match, then you need to reject. Earlier what used to happen, if there is no match, then you reject. But now, if it is matching this list, then reject. It means that if your input is Nazi, so if you're getting this as true, if this flag is true, then you reject it. That's the logic. If this is true, then you reject the thing. So let's call that here. So go here and create a graph function, gr reject blacklisted customers or blacklisted. Right, I'm going to call the, you can't drag and drop here. Okay, so you have to just say add function and call that here, CL blacklisted customers. Right click, expanded mode. uh, Input will go to the input. Do I need to use the search type? Let's not use it. Let's see what's the thing. Okay, now I need to play around this match flag. If the match flag is true, reject. False, accept. It means if the match flag is true, right? So but I need to convert this boolean to something useful. So right click add function. First of all, let me convert this boolean because I don't understand this boolean. So converts a boolean to the string, right? So what I will do is this to here. So if it's true, then reject. So add a constant and just say reject. If it's true, then reject. If it's false, then no problem. Proceed. Right? Let me quickly check this logic. I'm trying to build it step by step. So instead of creating a very big logic, I'm trying to test it. I'm taking full advantage of this test feature, and you should also do that. Okay, because it's a very quite a good feature. So if I give Nazi, I'm getting reject. That's working fine, right? And Hitler also, Hitler reject. So this is working fine, but I think I have, let me do a recursive search, or sorry, a extensive testing. So if I say Nazi Sunil, then it does not work. Nazi Sunil, it's not working, but it should work. Nazi Sunil is also a blacklisted customer because, for example, you can understand blacklisted. Okay, so to do that, I will give the search type. I'll use the search type. Search type can be what? What should I use? The search type anywhere, word, entire. Should I use anywhere? Let's see what is the problem with anywhere. So save it. So this is working fine. Nazi Sunil, it's working fine, right? But if I have Nazi Sunil, K-N-A-Z, I'm not sure if you can see that. Is this valid? Yeah, this can be valid. What's the problem? Or let's say Nazil Sunil. This is valid, right? But if I give that, it will reject. Reject. So the search type cannot be anywhere. It must be word, right? So that's the use of word. That's how and where you need to use the word. Now proceed. But if I use Nazi as an independent word, then it detects the reject. See here, right? So it is detecting. Now I can go ahead and add a condition that I need to create two values, reject, proceed. So add two things. So reject, one more, proceed, and delete this one. So if it's proceed, just proceed. If it is reject, you add a reject function. Add function, reject. How does reject function work? See, reject function is just like you have error function in Power Center. You just call it, it errors out. So input to this to this, and give a message. I'm going to give a message that um, blacklisted customers. Okay, and
Mm,
yeah,
I have a question here. So whatever the error message we are giving here, so it is only for testing purpose we can use, right?
no, testing purpose means what? In you will see this error message in the reject table.
Okay, this message will be visible in the error table.
Yeah, in the reject table you will see this message. So that's, it's always very meaningful. You should give a proper message so
Like
that you
even the
will
previous
understand
one,
why
that
it was
it
rejected. You will understand why it was rejected so that you can correct accordingly.
okay.
Okay, so this
And
should
what is the star brackets in star is the
default,
default value when
default.
we create it.
Yeah,
Yeah.
default. So default, it means if you give proceed reject, That's fine. If you give XYZ, it will go to reject only. But in this case, it's not
Okay.
necessary because I'll have either reject or proceed. So in my case, it does not make any sense, but it makes sense when you have more than two values.
Okay.
So this one will go to the case and input, drag it from here. So it looks like again a circle, web, no problem. In MDM, this is perfectly valid. And output goes to the output here and save it. You can't arrange it. You have to drag and drop like this. So if I select this Nazi Sunil, rejected. If I select Nazi instead of Nazi, so output is Nazi Sunil, working fine, right? Now let's complete this thing. Call this gr rejected blacklisted here. So add function gr rejected blacklisted. Okay, that completes the logic for this. I can shorten this compact mode, compact mode, compact mode. Okay, save it. All right, now you can do an extensive testing. So you can do that later. I'll just show you. Nazi Sunil. So output is Nazi Sunil, and if it is something like this, it'll clean also. So it's working fine. You can test it. It'll work fine. Okay. So that's the first logic, the cleansing logic for the name. It's quite a big thing because like a lot of things we are doing in here. And what you can do, assignment for you is when I've created this one, gr rejected blacklisted, I'm creating two things. You try to make it more reusable. You create um, this logic separately, and this logic you can create separately. Two graph functions you can create actually. Okay, so you can try that. That's the logic for that's the first thing. Now the second thing, organization name. See, organization name, the logic is pretty much same as the earlier thing, but there are some variations in the sense, see here, you would have seen something like this. There are some companies, some websites and some companies, you will see numericals also permitted in company's name. In company name you might see certain uh, 123 limited. So this is permitted. You might have certain numericals in the name or some characters, very few characters. Some characters are also permitted in the organization name. So like, so for example 3M technologies as posted. So you might have, this is perfectly fine. So you can understand that in here in the name, digits are not fine, of course not fine, plus you the characters are also, I mean like special characters or anything apart from alphabets is not fine, but here I must allow digits, plus I I must have I must allow certain uh, thing, like let's say underscore is permitted in some country, so you must allow that. Okay, so the logic for this is same as the way I have done that, same as this. And in the regular expression earlier we have given this, if you remember, we have given A to Z, then A to Z, then space. That's what we have given in the name. Instead of that, you change it to, for company name you change it to here 0 to 9. First digits are permitted now, right? Now let's say underscore slash, these two characters are also permitted. So this is the regular expression you should use to validate the organization. Remaining thing is same. You need to create one more noise filter also. Okay, and that noise filter you use this expression, right? And remaining thing is just same as the name one. And if you have any ideas, you can also use that to replace the thing. Plus one additional thing will come here, that is, you understood, right? So whatever we have done here, same thing you implement in here with this difference, that is this thing, this new thing. I'll also uh, put it down here. Okay, plus one more additional thing, that additional thing is replace a company noise. So replace company noise means you might have some, you might get something like Cisco India, or let's say Cisco Private Limited, and somewhere you might get Cisco Inc., or somewhere you might get Cisco Corporation. All of them are Cisco only. Okay, so this is considered as a noise again. This one, this one, this one, unnecessary thing. That's the noise, and I want to block that. I want to remove that. How do I do it? So Informatica already by default it gives a filter that is company noise. You can use it, or you can enhance that, or you can create your own. So it has these entries: company, company Inc., co, and all that thing. If you want to create your own, or if you want to extend that, you create your list here. Fine, no problem. Okay, but you have to use this. You understood, right? Apart from what we have done here, you also need to call one more thing. So you can create a graph function where you can call this thing, the replace company noise. I'll just show you by executing that. Let's say I have Cisco. So let's say Cisco Inc. And the output what I want is Cisco. Test it. It's not working fine, right? So this is case sensitive. Give this anywhere. Data is not case sensitive, but this option is case sensitive. Test it. So it's working somewhat, but you can see here that CIS co is getting replaced. So that's why this is another example where you need to use the word. If you use word, this is getting replaced. See here. And that's the output that I'm expecting, right? So you need to call this graph function, but just one precaution is use word. Do not use anywhere. It won't work. And if you have something, you can add this list like technologies. I think technologies is missing. So all those things you can, all the standardization things you can add it. How will you know in your real-time project, how will you know that this list, who will give you? Business analyst will give you. How he will know? Data profiler will do the data profiling. There you will understand that, okay, these are all the noise characters. Okay, and this list is also dynamic. Like once you start the project, later you will also need to change, like add few more entries, like that. Keeps on growing, right? That's the logic for this. And if organization name is null, reject, same as the earlier thing. You can reuse most of the components here. And blacklist, check, which is very important for organization name, because you can understand you should not have allow blacklisted company names, like you can understand, right? So those kind of, you can create a separate cleanse list for this blacklisted check. Separate cleanse list you can create. That's the logic for the company name, cleansing of the company name. And normally what cleansing we are doing is more than enough. In your project also, I don't think you will do anything more than that. Okay, in fact what we are doing here is slightly complex than most of the real-time projects, because my idea is to combine all the abilities, all the things that we have, like the graph function, cleanse list, regular expression, in a single mapping sheet. So that's why I have designed it like this. Then the status. Let's talk about the status. In the status, I just need to standardize it. If it is 0, 1, output should be active, 0, 2, inactive, or anything else unknown. We were talking about unknown yesterday, right? We'll see that today, how to use it. Logic is simple. If it is 0, 1, translate it to active, 0, 2, inactive, otherwise unknown. Alright, now how do I implement it? Same thing, same old story. So create a graph function, create a cleanse list. Why am I going for cleanse list always? I mean, like, can I implement this using a condition? Is it possible to do it using a condition? Like, I have a condition thing, right? Like this one. So what I'm saying is this, I can add a condition, and can I create like 0, 1? So I'll show you. Let me show you. Create a graph function first. gr standardize, or you can give std, that is enough, or st is enough. sta, I'll give full name, standardize status. I can do it this way also. I can say add a condition. I can say 0, 1. I can create one more, 0, 2. Okay, and this is unknown. Okay, and if it is 0, 1, I can create a constant and say active, and do it like this, something like this here, inactive, and in case of unknown, you just say add a constant, say unknown. You know this old stuff, right? Save that, and I need to pass this to the case value, not to the input this time. Alright, and output to here. So what I'm doing here is 0, 1 active, 0, 2 inactive, unknown. So if I go and test it, then save it. This is not the correct way, I'm just showing you an alternate way. 0, 1 active, then anything else unknown, 0, 2 inactive. Okay, so this is one method how you can do it. So let's say that I will just say like this is, I'll just say old. Okay, so this is one way in which you can do it, but the problem is, like, tomorrow if you get something else, tomorrow if you get, if your business is telling you that okay, we want 10 more entries, so we want you to create if it is 0, 5, then it should be pending, something like that. Then you need to go and change the code. That's not preferable. You should not go and change the code, right? So that's why we will use the cleanse list, which is better, because in the cleanse list I need to change the data. I am not changing the code, you understand? I am adding the list. I'm not changing the code. Here I'm changing the code. There is a difference. Is there any difference? Yes, there is. So say add a graph function. Now let's do it using the cleanse list. First you create the cleanse list, add cleanse list, cl standardize status, right? You create entries like 0, 1 active, active, then 0 to inactive, then yeah, that's it. So go here, 0 1 active, 0 2 inactive. Anything else? Nothing. So you use the unknown here, unknown. You can observe one thing, that unknown is coming to, like, it's getting populated in the matched flag, not in the output. So we are going to use the match flag as the output, not the output. We are going to use the match flag as the match, sorry, not the match flag, the matched as the output. All right, now working fine, but if my input is active, then what? Still going as unknown. So to prevent that, I'll create a dummy entry. The dummy entry is active to active, and inactive to inactive. Inactive. All right, now if I give active, working fine. Or I can even use more standardization. That is, what I can do is I can use active A for active and I for inactive. So this is another advantage of a cleansed list over the old method, or not the old, this is the just a different technique. I wouldn't say old, but a different technique. So, right, so I have A converts to active, working fine. All right, now call that thing in the graph function. So call it CL standardized status, this one. All right, now input to here. Do I need to pass anything to the search type? I'm not using that. I mean, the default entire is fine, not a problem. But this one will be the matched one, not the output. Is it working fine? Let's check it. 0 1 active, A active, I inactive, and anything else? Unknown. Okay, it's not coming as unknown, it's coming as null. So I have a problem, right? So this is called as backtracking. Now I need to understand why I'm getting this null. Let's check it. Output match flag. The reason is, you can see the default value I'm not specified. So I must specify a default value, that is unknown, right? So that's how you backtrack. Unknown. Save it. Should work now, right? Unknown. All right. So done. You can call that function here, gr standardized status. The organization name, you do that because it's just a repetition, so I'll not do it. I'll just tell you the new logic, so that remaining thing you can do it in the lab. Okay, and that's the requirement for the second thing. We'll try to complete it with this one so that you can practice it. Then the third thing is the party type. The party type, logic for party type is, you have to do validation plus standardization. Let's just talk about validation. The logic is simple. You accept only person or organization. So if it's a person, or accept it. If it's organization, accept it. Anything else, uh, if it's anything else, then you don't accept it. Okay, uh, just give me 1 minute. 1 minute. Okay, fine. Now here, accept only if it's person or organization. So anything else you reject it. Anything else you don't accept that. So to implement this again, same thing. 1 minute, just 1 minute. Okay, so if it's person or organization, then accept it, otherwise reject it. So the same thing, create a graph function, create a cleanse list. So graph function gr validate uh, party type, right? And then a cleanse list. Right. So in the cleanse list, you create entries like just a dummy entry. Again, I'm telling you this can also be done using the old technique, but this is always better. Sorry. And then organization. Okay. So simple. If it is person, you will see the match flag is true, right? If you see organization, it will be true. If it is anything else, you will see the match flag is false. We're going to play around the match flag now, right? So go to the graph function, call this cleanse list that we just created, validate party type. Okay, so play around the match flag. If match flag is true, valid, right? Otherwise invalid. So convert it first of all. So format boolean, convert that. Um, if it's true, valid, right? So give valid here. Otherwise it's invalid. So invalid, valid, save it. Let me test this quickly before proceeding. So if it is person, doesn't matter, it is not case sensitive. Data is not case sensitive. Okay, and if it's organization working fine, right? Anything else invalid, right? Then it's simple, you just add the uh, condition, and the condition should be, this should be exactly same as this value, valid invalid, should not be any spelling mistake. Valid, and I can edit this one as invalid. Okay, so valid, just pass it. Invalid, add a function, the reject function. Input to here, then give a message. What is the message we can give? Not in valid list, something like that. That's a meaningful, because when a record gets rejected, it will show you this message. So using this message, you can understand why, what is the problem with my data. So this is very important, this message. Okay, valid, this is the logic. Invalid, this is the logic, right? Now complete that. This will go to where? Case value, input, output here. Save it, and JFK not in valid list. If I give person in this or person in this is working fine, right? But if I give PER, it's rejecting. Now let's say I can also get PER from the source. PER means person only, right? So I can, to prevent that, what I can do here is I can go here and I can also standardize it. So I can say PER, translate that to person, and organization org to organization, right? So here if I'm trying to test a PER, output is PER. So this is wrong. Output should not be PER. Output should be person. So let's backtrack it. What is the issue here? What is the problem? Just see this. The problem is this. I must take the input from here, right? Not the source. So take it from here. Should work fine now, right? Person. It's working fine. That's the logic for the party type, and you complete the mapping by calling that add function, then validate party type, then party type here, then party type here. Save it. Right? That's the logic for the party. So the party is done. Then the last update date, which is direct 1-to-1. So you can directly connect it like this, or you can say right click and say auto mapping. So automatically this will connect the names. If the name is same, it will just automatically connect it and save it. Right? So we are done with this mapping, and in the query parameters you have to give a condition like src is equal to ckr, so that see, whatever condition you are giving here, what will happen is when Informatica is executing this mapping, it will use this query select star or column name from c underscore lnd underscore party, where whatever you put in the condition here, that will be copied here. So you know that landing table is a shared table, so I must pull only the relevant data. So that's the logic to pull the relevant data. Okay, so yeah, I think yeah, that's it. So I think we'll finish the session with that. If you have any doubts, you can ask.
Well, yesterday's recording is not available.
Sorry, what is?
Yesterday's recording. Yesterday's
It's not uploaded.
recording will no, I
Okay,
don't
okay.
see that.
Fine, fine. I'll upload now.
Thank you.
Right. Any more questions? Okay, no problem. Then you try to complete this lab, because tomorrow I think this is almost done, because I won't do all of it. I'll just, whenever it is wherever it is easy, I'll just skip that. I'll just tell you the difficult things. So we'll try to complete this tomorrow, right? Okay, thanks guys. Thank you very much.